Determinants and inverses. Two different things, two different formulas, but you need to be able to do the determinant to do the inverse. So what is the determinant? It's just a number that you calculate using the elements in a matrix. And you need to be able to calculate the determinant to be able to do a few other things. Solving systems of equations, that comes into play, but what's really important right now is that it's needed to find the inverse of a matrix. So we have to learn how to do this first before you can learn to do the inverse. The symbol for a determinant, if we're talking about the determinant of matrix M, would look like this. Looks like absolute value. So, but in the matrix world, it's the determinant of matrix M. Most of the time, I will just say find the determinant, or you can even put DET for determinant. You can only find the determinant of a square matrix. So no 2 by 3s, 1 by 5s, nothing like that. It has to be a square. 2 by 2, 3 by 3, 4 by 4. I'm only going to teach you how to do a 2 by 2. That's the easiest. The bigger the matrix, the harder it gets. 2 by 2 is the only one that you would need to know for like ACT or something. But you can do it on the calculator as well. So here's the formula. The formula itself is easy. It'll just be remembering it. That's what makes it hard for you. So if you have a 2 by 2 matrix, and we label the elements A, B, C, D, the formula is A times D minus B times C. So you do A times D minus B times C. Kind of like cross multiplying-ish, kind of. A lot of people think of it that way, and that helps you remember. But it is important that you do. So when you're subtracting, it matters which one is first. So number 1, I'm going to do 5 times 0 minus -1 times 3. And what is 5 times 0?
0.
Minus -1 times 3.
3.
And what is 0 minus -3?
3.
Positive 3. A minus and negative turns into a plus. So 0 plus 3. Any questions?
Is that it?
That's it for determinant.
Yeah.
Well, I don't think it's as easy because you have a formula to remember. But it's still pretty easy. All right, number 2. 7 times 2 minus 1 times 6. What is 7 times 2?
14.
Minus 1 times 6? What is 14 minus 6? 8. Good. Try numbers 3 and 4 on your own. Suzanne, what did you get?
I got -1.
-1. Do you all agree?
Yes.
Good. Number 4, Aiden. -4. Do you all agree?
Yeah.
Yep. 20 minus 24 is -4. That is correct.
When we get to the point where you gotta do the rank
I will probably tell you to show your work.
Okay.
But I promise it's not going to make your hand fall off from too much writing.
I know.
It's very minimal. Alright, your calculator does do the determinant It's probably slower if I give you a 2 by 2, it's probably faster for you just to do it by hand. But calculator steps. So look here above this X with the -1 button. You see in blue it says matrix. Okay. That, if you go to that menu, there's a lot of things that matrices have, or to do with matrices. So to get the blue, you hit second, and then hit the X with the -1. And you'll need to scroll over to math. That has all of the calculations that you can do with matrices. The first one, DET, stands for determinant. So hit enter. And then you type in your matrix. This example that I've given you down here is a 3 by 3. How do you get to do a matrix? Alpha zoom. And we want a 3 by 3.
So if it's not a 2 by 2, do you multiply the middle numbers as well, or just the
No, and actually I don't remember the exact steps, but you have to like cross out a row and a column, and you do the determinant of that, and then you cross out that column and that, and do determinants, and then you do something with them. I don't really remember the full. It's been a long time since I've done
doing
it.
that?
No,
Oh, okay.
you only have to do a 2 by 2 by hand. I mean, it's not hard. It's just a lot of steps, kind of like multiplying. Not hard. It's just a lot of calculations.
This will make you feel Christmas to type all these.
I know. So it takes. That's why a 2 by 2. It's faster just to do it by hand. And you hit enter, and you get 39.
The 4 by 4 be easier because it'll have all of it.
It's still harder.
Still weird.
It's harder, yeah. The more you get, the more calculations you have to do. All right. Any questions on determinant? Turn over so we can do the inverse. A little bit more to it. Okay. So the inverse, and I talked very quickly about it, like the very first lesson we did. Talked about the inverse. The inverse is similar to what you might have heard as the reciprocal of a number. You've probably heard that word before. When you learned about perpendicular lines in Algebra 1 and slope, their slopes are negative reciprocals. So you like flip the fraction and change the sign. It's kind of similar because when you have a number, if you have 5, its reciprocal is 1 over 5. And when you multiply those two numbers, you get what? 1 over 5 and 5 when you multiply them. 1. 5 times 1 over 5 is 1. 10 times 1 over 10 is 1. When you take a matrix and multiply it by its inverse, you don't get 1. Do you remember what I told you several days ago that you get? You get that identity matrix. Remember, it's the one that has the ones going in the diagonal and then all the zeros. So when you take a matrix and multiply it by its inverse, you get the identity matrix. So matrix A, if we're talking about the inverse, we give it a -1 exponent. You saw that in Unit 1 when we talked about function inverses. The -1 exponent means inverse. When you, like I just said, if you take a number and you multiply it by its reciprocal, you get 1. But if you take a matrix and multiply it by its inverse, you get the identity matrix. Now here's this next thing is really important. Put a star. you're going to have to calculate the determinant to be able to do the inverse. If the determinant is equal to 0, the inverse does not exist. And as soon as I give you the formula, I'll explain why. It's okay for your determinant to be 0, but if I ask you for the inverse, you would have to say it does not exist. So here's the formula. A little bit longer. First, you have 1 over the determinant. If your determinant is 0, that puts a 0 in the denominator. Can you divide by 0? Nope, that's why it doesn't exist. Okay. So you do 1 over the determinant times a matrix. In this matrix, A and D switch places. Yeah, they just swap places. So whatever number's in the top left and bottom right. Okay.
After you find the
It ends up, yeah, it ends up not. Switch sign. So they don't switch places, they switch signs. So B becomes negative B and C becomes negative C. If it's positive, it becomes negative. If it's negative, it ends up becoming positive. And then when you calculate that, you multiply the number in, you get your inverse. So let's do a real example. So number 5, you have to start out by finding the determinant. Just find the determinant of the original. So you have 5 times 1 minus 3 times 1, which is 2. So then to find the inverse, we have 1 over 2 times, so the 5 and the 1 switch places. And then the 3, this 3 and 1, they're both positive, they both become negative. Negative 3, negative 1. When you multiply something by 1/2, it's the same thing as dividing by 2. So if I take 1 divided by 2, I want you to leave your answers as fractions. So that would just be 1/2. Negative 3 times 1/2 is negative 3 over 2. Negative 1 times 1/2 is negative 1 over 2. And 5 times 1/2 is 5 over 2. If I was multiplying by 1/3, I would put over 3. If I was multiplying by 1/5, I would put over 5.
But always leave it as improper fraction.
Yeah. Now you could also type this in, I could do a fraction, 1/2 times, and all of this, but again, it would be faster to just do it. 1, 3. And that's your inverse. If I took my original times the inverse, it would give me the identity matrix.
So, did you say that this stuff doesn't apply to real world?
I mean, matrices do in general. Like, no, I mean, there's a lot of behind the scenes programming that matrices are used for. Are you going to go out to the store and use it? Probably not. But matrices are used. A lot of computer formula, generated formulas and stuff come from them. Alright, number 6. Start by finding the determinant. Zero times 2 minus -1 times 0.5. Zero times 2 is 0. -1 times 0.5? -0.5. So 0 minus -0.5 is positive 0.5. So my formula is 1 over the determinant. So kind of weird to leave decimals in a fraction. Type this into your calculator and tell me what you get. You get 2. 1 divided by a half, 1 divided by 1/2 is 2. So I can write this as 2 times the matrix. So 2 times the 0 and 2 switch places. The -1 becomes +1, and this 0.5 becomes -0.5. So 2 times 2 is 4. 2 times 1 is 2. What's 2 times -0.5? -1. And 2 times 0 is 0. Any questions? Number 7. Determinant. -5 times -4 minus 10 times 2. -5 times -4 is +20 minus 10 times 2, 20. What's 20 minus 20? 0. The determinant is 0. But what about the inverse? Doesn't exist. The inverse, you can put DNE, does not exist. Try number 8 on your own. you should get 8/3, -3, 1, -1. Any questions? Your calculator will do the inverse by hand. Or the calculator will do it, sorry. So you don't have to do it by hand. So if you type in your original matrix and raise it to the -1 power, your calculator will do all of the work for you. You don't need to switch anything, change signs, none of that. You type in the original problem. Seven, 4, 3, 2. And this button right here will give it a -1 exponent. And then you hit enter. And it'll give you decimals, if there are decimals in it. So you can convert hitting the math button, enter, enter. And it'll convert everything to fractions.